So let me remind you that you have quizzes due this week, and you are required to watch all of the video lessons that are posted for this week in the class Moodle page. Make sure you always have a blue tick beside the videos that you watch. That way you know that they've been registered as complete. That is your responsibility. In this lecture, we want to talk about the properties of functions. We're going to use these properties a little bit now, but they won't come up again until we talk about trigonometry and graphing trig functions. So you will need to remember these definitions because we will use them again. Let's start with an even function. We say that for an even function, the f of x is equal to the f of negative x. What that essentially tells us is that if the x's are the opposite of each other, then the y values are the same. So for every point, every ordered pair x, y on the graph of the function, the point negative x, y is also on the graph. So that means, for example, if we have the point 2, 3, then we will have the point negative 2, 3. This graph is always going to be symmetric with respect to the y-axis. A good example of an even function graph is a parabola. It has the point negative 2, 8, and then it has the opposite of x, positive 2, 8. Did I say not 8? It should be 4. There we go. The x values are opposite, the y values are the same. We have an odd function graph if the negative of f of x equals the f of negative x. So notice here, when the x values are the opposite of each other, the y values are the opposite of each other. For every point x, y on the graph of an odd function, the point negative x, negative y is also on the graph. So if we have the ordered pair negative 2, positive 3 on the graph, then I would have to have the opposite of x, the opposite of y also on the graph. This graph rotates 180 degrees about the origin. Remember, the origin is that point 0, 0. So a good example of an odd function is our cube function graph. Here we have that point negative 2, negative 8, and we have the opposite of x, opposite of y on the graph. And if I could turn my computer 180 degrees, holding it there on the origin, the graph would look exactly the same. So this y equals x cubed is a good odd function graph. Here are 3 graphs, 1, 2, and 3. Can you determine whether they are odd, even, or neither? The first one is neither. It doesn't reflect across the y-axis. It doesn't rotate 180 degrees. The second one is even. We have symmetry on point on either side of the y-axis. The third one, if I put a pin at the origin and rotate it, would be exactly the same. This one's an odd function. We can see that by looking at a graph, it's pretty easy to determine whether a function is odd, even, or neither.